Okay, on to example 16. I noticed that 7 is divisible into each term, so let's factor a 7 out. And I'm going to factor a positive 7 because my y squared is positive. I want it to stay that way. Okay, this is a really simple AC factoring. Okay, you could probably do this just as fast using trial and error. So 2 times -3 gives me a -6. The factors of -6 that will give me our middle term of -y is going to be, coincidentally, -3 and -2. So that means instead of having that -y there to aim at, I will rewrite that as -3y plus 2y minus 3. That makes the next factoring step hopefully really simple. My 2y squared has to be 2y times y, because 2 is prime. So what do I have to multiply? What do I have to multiply 2y to get one of these two? Well, I can't really multiply 2y by anything to get this -3y. So it has to be multiplied in order to give me the positive 2y. So that means that I will be multiplying by, I'll multiply 2y by this -1. That will give me that -2y. Then turn around, look at this y. What do I have to multiply that by here in order to get the -3y? Well, that's -3. Okay, I don't like this because my signs are wrong, I think. -3y, 2y, here's my error. Yep. So that should have been a positive 1. That will give me my this -3. I've got that -3 and then the 2y, and I added example 7 to your notes, and I do apologize for not being totally prepared. I added example 7, so go ahead and add this example. And I am going to write, so on page 31 they show you the sum and difference of 2 cubes. How do I know this is either the sum or difference of 2 cubes? Well, I'm pretty sure because I have exactly 2 terms, and I have a perfect cube on the left and a perfect cube on the right. So my pattern for this, though, is if I have a to the third, well, first of all, let me factor out this negative. Let's get that out of the way. -64z to the third minus 27. We're going to ignore the negative and then factor the difference in 2 cubes. So my pattern for the difference in 2 cubes on page 31 is real similar to the sum of 2 cubes. Makes it somewhat easy to remember. Is going to be a minus b times a squared plus ab plus b squared. Now, that trinomial you get, this always happens with the sum or difference of 2 cubes, is not factorable. So you don't even have to worry about it. Okay, so my trick here is to identify a and b correctly. So the cube root of 64 is 4, and the cube root of z to the third is z. So I can rewrite this as 4z all cubed minus 27 is, the cube root of 27 is 3, minus 3 to the third. That means that a is equal to 4z and b is equal to 3. I'm going to substitute them into that pattern, but on this particular problem I've got to drag around that negative, so I will start with that. So here's my negative, and here is a minus b. Okay, so I'm just substituting into that pattern, and then 4z squared is going to be 16z squared. A times b will give me 4z times 3, or 12z, and then b squared is going to give me 9. I'm done. All right. Hopefully you've been able to take the 1.2 quiz, and I will see you in class. Bring your notes.